Hello students, welcome back to my YouTube channel Data Shah. I have started a new series that is the solutions to the system of linear equations, and we are doing direct methods. So you can refer to my earlier lectures where I have covered the Gauss elimination method, Gauss-Jordan method. These are the direct methods, and today I am talking about the LU factorization method or the LU decomposition method. So basically, in this lecture, we'll be talking about what is actually this method all about, and we'll be doing one or two questions related to that. So particularly when we talk about in this method, the coefficient matrix that we have, the coefficient matrix that is we are talking about A, right? The coefficient matrix A is decomposed into the product of two matrices. So those two matrices are the one is lower triangular matrix and the other is upper triangular matrix. Now, when we would be having a question like you would be given a system of equations, or you would be given a matrix to find out the inverse, or you would be given a question that just decompose into LNU form. That's it. So such kind of questions you need to figure out what they are asking you to do. So LU, the name suggests L denotes the lower triangular matrix, and the U denotes the upper triangular matrix. So as we all know, what is an upper triangular matrix and a lower triangular matrix? So I'll give you a rough approach how to deal with it. So suppose you are given a linear system of equation. Ax is equal to b is a linear system given to us, and A is our coefficient matrix. So now we'll assume that A is equal to LU, where L stands for a lower triangular matrix and U stands for a upper triangular matrix. So you can write here where L is a lower triangular matrix and U is an upper triangular matrix. Now I'll be substituting this A value in the system of equations, and let's see what will happen here. So let me take this as 1, 2. So using 2 in 1, we get LU times X is equal to B. So I can also rewrite this as this. So let me assume this to be some Y. So put ux is equal to some y. Now, in this, we have an equation that is L into y is equal to b, and we can solve this equation using the forward substitution because L is a lower triangular matrix, so it would be solved with the forward substitution. Now, when we have calculated the values of y here, then after that, we'll be calculating the values of x from this equation. So, let me denote this. So, the solutions of the equation 3 will give us the values of y using forward substitution. Whereas the solution after this the solution of equation 4 will give us the value of x, that what we need to find using backward substitution. How can I say that it would be backward substitution or the forward substitution? Forward substitution, the reason is here L is the lower triangular matrix. And in case of the backward substitution, why? Because here is the upper triangular matrix, right? So due to that, I'm saying the forward and the backward substitution. So let me take one example in which I'll be finding the inverse, and then we'll be solving a system of linear equation using the LU factorization method as well. So consider the question where you are using the factorization method. It is also known as factorization, decomposition, LU decomposition. There are different names. Find the inverse of the matrix. So A is given to us as a 3 cross 3 matrix. Okay. So need to use the factorization method to find the inverse. So how to start this question? Let A can be written as LU, where L is a lower triangular matrix and U is an upper triangular matrix. But here, one thing you need to keep in mind that L, that is the lower triangular matrix, has the diagonal elements as unity. So where, okay, where L is and I'll write the other elements as L21, L31, L32. And U is given by, because it's an upper triangular matrix, so U11, U12, U13, U22, U23, U33. So this is an upper triangular matrix and this is the lower triangular matrix with the diagonal elements as unity. So this is important that in factorization method, we need to keep this thing in mind. Now, as I know that I have assumed to be equal to L multiplied by U. So I'll be just substituting all the values in the equation 1 and I'll get the left hand side is my matrix A. So I'm just substituting the values here, which is equal to L and then U. I'll multiply both of them. And then we'll compare the values later. So when I multiply these two, as we know how to multiply the two matrices because they are of the same order, so we can multiply them. So let us see what we'll get. This is the way we used to multiply. So first row with the first column will give you the first element. So 1 multiplied by U11, 0 multiplied by 0, 0 multiplied by 0. So I'll get only U11 in the first place. Then the first row, second column will give you second element of this resultant matrix. So that would be again U12. And lastly, I'll be getting here U13. So let me just write with the spacing. Okay. Then the second row with the first column, again, I'll be getting here L21, U11. Second row with the second column, I'll get L21, U12 plus U22. Second row with the third column, I'll get L21, U13 plus, let me just erase this. And this would be U2, 3. Then last row with the first column will give me L31, U11. Last row with the second column will give me L31, U12 plus L32, U22. Last row with the last column will give me L31, U13 plus L32, U23 plus U33. So these are the elements that I'm getting. Now, as we know that this matrix is equal to this matrix, so equal matrices are always comparable. Comparable means that their corresponding values, like this value would be equivalent to this value. So what we need to find out here? Uh, I need to find out the inverse. For that, I need to find out first of all what is L and what is U. That means the unknown values L21, L31, L32, U11, U12, and so on, all the UIs. So how could I find them? By comparing these two matrices. So on comparing, we get the values. So it's very easy. The first row would be the same as the first row of the matrix A. So I'll get U11 as 50, U12 as 107, U13 as 36. Then L21 U11 is equivalent to 25. So as I know U11, so I can get the value of, so this will give me L21 as 25 upon 50. That will give me the value. Yeah. So that would be half. I'll get the value as half. Then I'll just draw the line so that it becomes easier for me to calculate. Okay. Now L31 U11 is equivalent to 31. So L31 U11 is equal to 31. So L31 would be equal to 31 upon 50. So I'll write here 31 upon 50. There is no cancellation. Now next L21 U12 plus U22 is equal to 54. So what I'll get, I know the value of L21, I know the value of U12. I'll just substitute. So I am getting here 107 upon 2 plus U22 is equal to 54. So I can calculate the value. U22 is coming out to be yeah. So U22 is coming out to be, when I'll solve, this would be 54 minus 107 by 2. So that will give me half. Now, after this, the last value is equivalent to 20. So L21 U13 plus U23 is equal to 20. So L21 I have already calculated, that is half, and U13 is 36. So 36 upon 2, that's 18, plus U23 is equal to 20. So I am getting 20 minus 18. So U23 is equal to 2. Then the next value, L31 U12 plus L32 U22 is equal to 66. So putting all the values that we have calculated up till now, L31 I have calculated as 31 upon 50. U12 is 107. So this becomes 31 upon 50 into 107 plus U22 is half. So L32 and this is half is equal to 66. So after all the calculations, I am getting my L32 as minus 17 upon 25. And lastly, I'll be calculating the value This is L31 U13 plus L32 U23 plus U33 is equal to 21. So substitute all the values that we have calculated up till now. L31 is 31 upon 50. U13 is 36. L32 is minus 17 upon 25. U23 is 2 plus U33 is equal to 21. So finally, I'm getting my U33 as, after doing all the calculations, I'll get my U33 as 1 upon 25. So let me just highlight all these values. L21, L31, U22, U23, L32, and all these. So this is what we have. Now what we need to do, we need to find out the inverse. We'll find that, but first of all, we need to substitute all these values in the equation 1. So let's move ahead. Thus, our L is coming out to be 1, 0, 0, 1, 0, 1, half 31 upon 50 and minus 17 upon 25. And my U is U11, 50, 107, 36, half to 1 upon 25. Now, what we need to do, we need to find A inverse. Now we know that A is equal to L into U. So that means we need to find out this value. Now what is this? This is nothing but U inverse into L inverse. Why this is so? Because we know that AB whole inverse is B inverse A inverse. So let me just write it properly. B inverse, the inverse values. This is the property of the matrices and determinants. So we know that. So what is the final answer? The A inverse you can find out by just calculating U inverse and L inverse separately, and then multiplying them, you will get the value. I mean, you will get the answer. So now we'll find out the inverse of L and U here separately. So let us find L inverse. First of all, we'll be finding out the L inverse, and also you can then find out the U inverse. So there are two ways of finding the L inverse. As you could use the normal method that we know, 1 upon L determinant into adjoint of L. Either we could use this method, and there is another method as well through which we can find out the value of the L inverse. So this is the very easy method to find out, I would say, or the in the school times we used to find out the inverse using this proper formula. I'll tell you the another way to find out the L inverse. So what would that be? Either using this, or L inverse can be find out using find x such that L into x is equal to I. So this x is nothing but your L inverse. So I'll be doing this particular option, and I'll show you this with the, again, with the same, we can do that as well. So let me do it both so that you can just compare. So first of all, we'll be finding out the L inverse using this. So what is determinant of L? As we know, this is my value. So I am getting determinant of L as 1. So I'm just, you can just solve this, right? So this is 1 into 1 minus 0, minus 0, um, and then plus 0. So answer is coming out to be 1. That is not equal to 0, right? So determinant of L is coming out to be 1. Now what is adjoint of L? Adjoint of L is just the cofactors matrix transpose, right? So how to calculate the adjoint of L? So that would be my cofactor matrix transpose. So I'll just write, find it, and then I'll do the transpose of it. So let us find this. The first of all, I'm getting this as 1. Then this is my value half. This is coming out to be, just a second. Let me just calculate. This is 17 divided by 25. So this is 0.34, and we have 31 divided by 50. So that's, so let me write it in the decimal form. Okay. So 0.5, and this is, I'm getting it as to add both of them. So 0.62 plus 0.34. So I am getting this as 0.96. Then moving ahead with this, I am getting this as 0. And here this would be nothing but just 1. So lastly, I'll get here 17 upon 25. So 17 upon 25 in the decimal format is 0.68 transpose. So lastly, A31 is again 0, and this would also be 0. And then because it is a lower triangular matrix, so obviously the adjoint of L would also be the lower triangular matrix only. And lastly, I'll be getting here 1. So this is what I'm getting as my adjoint of L. So what would be my L inverse? Let me just erase this. My L inverse is nothing, but I'm getting this as um, just putting in the values. So taking the transpose, it would be 1 minus 0.5. This is minus 0.9. This has to be minus 0.96, sorry. And then this is 0, 0, and this would be 1, 0, and then this would be last minus 0.68, and lastly 1. Now this is the easiest and the original way of finding out the inverse. And also you could apply this particular method that I'll be telling you, find the x such that L of x is equal to y, I. Now x here, x is your L inverse, right? So you need to understand that you need to find out L inverse. So as L is a lower triangular matrix, so X would also be a lower triangular matrix. So that is your L that we have is 1, 0, 0, half 1, 0, 31 upon 50, minus 17 upon 25, 1. And this would be x11, 0, 0, x12, So this is what we are getting. So clearly X would be an upper triangular matrix. So as you could see here, L inverse is getting, we are getting an we are getting a lower triangular matrix. I'm so sorry. And similarly, X would also be a lower triangular matrix that we need to find out. Now, what you need to do, you just need to find out multiply these two matrices and equate it to the identity matrix, the elements of the identity matrix, and you will get the desired answer. So let us just quickly multiply this. So as we know, you need to multiply it like this. So first row would be multiplied by the first column. So you will get this as x11. First row with the second column, you will get answer 0. First row with the third column, you will get answer 0. Second row with the first column, you will get x11 divided by 2. And this would be plus x12. Then this multiplied by this, so you will get x22. Lastly, you will get again a 0. So last row with the first column will give you 31 upon 50, x11 minus 17 upon 25, x12 plus x31. And this would multiplied by the last row with this second column will give us minus 17 upon 25, x22 plus x32, and lastly 0. So let me just write it in a proper way. So this would be 0, x22, 0, 0. And we'll be comparing it with the identity matrix. So what we are getting when you are comparing these two matrices, first of all, I'll be getting the values of x11, x12, x22, and so on. So I'll need to solve these equations. So what you could observe here that so just a second, I have missed out one thing. So this has to be x33, and this needs to be x33 as well. So let me just x33. So you will notice on comparing, we get that all the diagonal elements are 1. So x11, x22, and x33 are all equal to 1. So we are also getting here all of them equal to 1. So now on the next page, I'll just compare the other equations. I'll write down. So this would be equivalent to 0. So let me just write it. x11 divided by 2 plus x21 is equal to 0. As we know that this is equal to half. So I am getting x2 is equal to minus half. So this is my second element that I have x12, sorry, x12. Now, next equation that you could put is the last one equivalent to 0. So let me take that 31 upon 50. x11 minus 17 upon 25, x21 plus x31 is equal to 0. So this is what I am getting here, right? So x11, this is x21 and so on. Okay. Now, I know the value of x11 here. So I'll just find out. So this is equivalent to, just a second. We were doing this x, I'm so sorry. This is x12 plus x31, right? So 31 upon 50 multiplied by 1, because here we are getting the value as 1 only. minus 17 upon 25, x12 is minus half, plus x31 is equal to 0. So when we'll calculate this, this would be plus 17 upon 50 plus x31 is equal to 0. So this is coming out to be 48. So x31 is minus 48 upon 50. That we can um reduce it further, and I'll be getting my x31 as minus 24 upon 25. Now the last equation that I have is this one, minus 17 upon 25 x22 plus x32. So minus 17 upon 25 x22 plus x32 equal to 0. So as I have calculated the value of x22, that is 1. So x32 would be equivalent to 17 upon 25. So now you could see here the values that I am getting: x32, x31, x12, and previously these values. So using this, I can find out x. So thus L inverse, that is x, is nothing but given by 1, 0, 0, 1, 0, 1. So minus half, x32 is 17 upon 25, x31 is minus 24 upon 25. So even if when you'll calculate these values, 24 upon 25 is your 0.96. And 17 upon 25 is 0.68, which is same as we have observed here. The same. So there are two ways in which you can find out the inverse, either this way or the that way, whichever way you find it easier. So obviously you need to choose one only. Now, what we need to do next, we have to find out the next U inverse. So I'll be using this concept only, so that that is find uh, y, which is equal to U inverse, such that U of y is equal to identity. That is your upper matrix, that upper triangular matrix that we have is 50, 107, 36. So y would again be an upper triangular matrix. So I'll take it as y11, y12, y13, 0, 0, y22, y23, and lastly y33 is equal to the identity matrix. Now need to multiply them. So it would be this with this. So I'll get 50 y11 with this, and then this with the second column. First row with the second column will give me 50 y12 plus 107 y22. Then lastly, I'll get first row with the third column, 50 y13 plus 107 y23 plus 36 y33. Then second row with the first column, I'll be getting 0. This is also 0. This is also 0, because these are two upper triangular matrices. You will get these are 0. You can cross check. Then second row with the second column, I'll be getting here y22 divided by 2. Then second row with the third column, I'll get y23 divided by 2 plus twice of y33. Last row with the last column will give me this. So that's y33 divided by 25. This is equivalent to the identity matrix. And on comparing we get the values. So y11 is coming out to be 1 upon 50, y22 is coming out to be 2, y33 is coming out to be 25. So this is easy. Now, first of all, this one, so this will give me 50 y12 plus 107 y22 is equal to 0. So I'll, because I know the value of y22, that is 2, so I'll just substitute here, or rather I'll just write the answer quickly. So y12 I am getting as minus 107 upon 25. Then this would be compared, so 50 by 13 plus 107 by 23 plus 36 by 33 is equal to 0. So y13 we need to find out, because we need okay, we don't know y23 either, so let me just put y23 y2 plus twice of y33 equal to 0. So from here, first of all, we'll need to calculate y23. Y33 is 25, so this becomes 50. So minus 50 into 2, that is minus 100. So I'm getting this as minus 100. Now I can substitute here. So this is 50. Y13 need to find out, plus 107 times minus 100 plus 36 into 25. So when you solve, I'll get y13, I'm getting this as 196. So I have got all the values, and I'll be substituting here in the upper this matrix. Okay, so I'll get the value of y, that is U inverse. Great. So thus U inverse, that is y, is coming out to be 1 upon 50, 0, 0. This is minus 107 upon 25. This is 2, 25 minus 100. This is 196. Okay. Now we need to find A inverse, that is U inverse into L inverse. So let us just quickly find that. A inverse is U inverse multiplied by L inverse. So that's 1 upon 50, 0, 0, minus 107 upon 25. And L inverse that I have calculated on the previous page. So L inverse is this. So let me just write it quickly. 1, 0, 0, 1, 0, 1, minus half, and this is minus 24 upon 25, and this is 17 upon 25. So when we multiply these two, finally we will be getting A inverse value. So I'm getting my answer as so this is the final answer that we need to find out. A inverse. Using the LU decomposition method or the factorization method, this is how we can calculate it. So I know you would be finding it very lengthy, but it is not, because this is the first time we are doing it. So it seems to be lengthy, but it's very easy. You just need to remember that in the LU factorization or the decomposition method, the lower triangular matrix diagonal elements are 1, and whereas the upper triangular matrix, it has all the diagonal elements are the normal one, and you can find out the inverse, or you can find the solution of the system equations that we'll be doing in the further videos. So this is the LU decomposition method. So stay tuned for the other videos, and I'll be talking about the different types of the LU decomposition in the upcoming videos that you will watch. So do subscribe to my channel and please hit the bell icon so that you can get the notifications for the new videos. Thank you.